Hey Algebra 1 peeps, this is Mrs. Snook with section 8.7, Factoring Special Cases. And what we're going to do in this video is we are going to factor perfect square trinomials and difference of two squares. And you've done this going the other way. I've already had you do things like, if I said to you x plus 6, you could then tell me that was x squared plus 12x plus 36. We're going to go the other way. We're going to start with x squared plus 12x plus 36, and we're going to get the x plus 6 squared. And same thing with difference of two squares. If I gave you x plus 6 and x minus 6, you could tell me that was x squared minus 36. Okay, we're going to go backwards. If I give you x squared minus 36, you should be able to tell me x plus 6 and x minus 6. So let's go ahead and get our first problem. So we've got two adjacent squares here, and we have their areas. And then in terms of x, how much taller is the left square than the right square? And what we need to remember is that the area of a square is the same thing as its side squared. So for my area is 25, each side is going to be 5. And then for the area of the larger rectangle, what we need to do is we need to factor that x squared plus 14 plus 49, and hopefully we'll get two factors that are the same because it's a square. So let's go ahead and factor this. So x squared plus 14x plus 49. My factors are going to look like this. I'm going to have an x and an x. 49 is positive, so we're going to have the same sign. And that sign is going to be a plus, so plus and plus. I want two factors of 49 that will add to 14. So here's 49. We have 1 and 49, or 7 and 7. And it turns out 7 plus 7 is 14. So then our area is just x plus 7 squared. So then this side here is x plus 7, and so is the top, or the up and down side. That's x plus 7. If I wanted to know how much bigger this side was from the other one, I would just subtract. So my large square, it has a side of x plus 7. And then my smaller one has a side of 5. So I just subtract that 5. And my answer is going to be x plus 2. Okay, so let's do some more example problems. What is the factored form of x squared minus 12x plus 36? Just factor this like normal. Don't worry about if it's a perfect square or not. I have a positive on the 36, so both signs are the same, and that sign is a minus. So I want factors of 36. They're both going to be negative, and they're going to make 12. So negative 1 and negative 36, negative 2, negative 18, negative 3, negative 12, negative 4, negative 9, negative 6, negative 6. And that's the one that's going to give me a negative 12. I could also write my answer like this. Now we're going to do this one, x squared plus 6x plus 9. X and x. Again, I have a positive 9, so both of my signs are the same. That sign is a plus, so I'm going to put a plus and a plus. I want the factors of 9. They're going to add to 6. And that's going to be 3 and 3. Or x plus 3 squared. So here's an idea. You could factor like normal like we've been doing, but if you notice the pattern, you can just write down your answer. And here's the pattern. if your first term is a perfect square and your second term is a perfect square, square root those two, multiply them together and double it. That should be your middle term. And if you have that, then you have a perfect square. And if it's all pluses, then it's an a plus b squared. On the other hand, if you have that, but you've got a negative in here, then you're going to have an a minus b squared. My advice is just factor like normal. So if I have an x squared plus 8x plus 16, if I square root the x squared, I get the x's. I square root the 16, I get the 4's. And I'm going to say, okay, 4 times 2 times x, is that 8x? It is. So this is a perfect square. Look at this one, the 4n squared minus 12n plus 9. Take a square root of 4n squared. You should get 2n. Take your square root of 9. You should get 3. And then check it out. I have a negative here, so it should be 2n minus 3, which is what they show over here. And then let's check and make sure that really is a perfect square. So 2n times negative 3 times 2, because I'm going to double that. That does give me 12n. So that is a perfect square. So my answer would be 2n minus 3 squared. All right, so let's do an application here. Digital images are composed of thousands of teeny tiny little pixels, and a pixel is a square shape, as shown in the picture below. Suppose the area of a pixel is 4x squared plus 20x plus 25. What is the length of one side? Well, remember as we started, area is going to be the side squared. So if I want to know the length of one side, then what I have to do is square root the area. Now it's given it to us as a polynomial, so I need to factor this and see if I get the same factor. If I do, then I have a perfect square and I can square root it. So let's do that. So I've got 4x squared plus 20x plus 25. Now because there's a 4 in front, I can slip and slide. That's option 1. Option 2 is pattern. I'm going to go ahead and slip and slide because I'm not sure this is a perfect square. So let's slip and slide. So I'm going to slip my 4. So I get x squared plus 20x plus 100. And then I'm going to factor x plus, x plus. Factors of 100 that add to 20 are 10 and 10. So that's my slip. Now I'm going to slide. Since I had to multiply by 4, I'm going to divide everything by 4. And then I need to reduce this. So x plus 5 over 10 times x plus 5 over 10. What am I saying? 5 over 2. I apologize. Now it's time for bottoms up. So I get 2x plus 5 times 2x plus 5. Those are both the same. So then I know my polynomial is 2x plus 5 squared. So now one side is 2x plus 5. The other approach is to use the pattern. So I have 4x squared plus 20x plus 25. I'm going to square root my first term, 2x. Square root my last term, 5 and 5. Now I'm going to check to make sure I've got a perfect square. So 2x times 5 is 10x. I double that, I get 20x. That does match. So my answer is going to be 2x plus 5 And then if I square root that, my side is going to be 2x plus 5. Both work. I do not care which way you go, if you choose to factor like normal or if you choose to use the pattern. It's fine with me. Now the next type we're going to do factoring is a difference of two squares. So take a look at A. We have z squared minus 9. So our first term is a perfect square. So this is a perfect square. Now look at negative 9. That's also a perfect square. And so if you recognize that and you see that you have a difference in here, that's a difference, that minus sign, you can literally just take the square root of your first term, so z and z, take the square root of the last term, 3 and 3. I'm going to put 1 as a plus and 1 as a minus, because that's the only way I get a negative on the end. So you can do it like that. Your other option is to introduce a middle term. So v squared plus 0v minus 100. If you put in that 0v, you can then just factor like normal. So v. I have opposite signs, so one's going to be plus, one's going to be minus, and I'm going to get factors of 100. So 1 and 100. 2 and 50. 3 doesn't work. 4 and 25. 5 and 20. 6 doesn't work. 7 doesn't work. 8 doesn't work. 9 doesn't work. 10. And then 10. And then it starts repeating. So I need factors with opposite signs are going to add to 0. So I can do a negative 10 and a positive 10. That equals 0. So 10 and 10. Either way works for me. So s squared minus 16, s plus 4, s minus 4. I did that using the way I did it the first one, checking the perfect squares for both and then the difference. I call that pattern. So I did this one using the pattern. And what these are is nice little shortcuts that will make your life so much easier when you get into Algebra 2. The next thing you can do is if you factor out a common factor, oftentimes you'll be left with something really, really, really easy to factor. So take a look at our 24g squared minus 6. I see a common factor of 6. So if I pull a 6 out, I'm left with 4g squared minus 1. Well, check it out. 4g squared is a perfect square. 1 is a perfect square. So I have a difference of 2 squares. So that says I can leave the 6 out in front and just factor my 4g squared minus 1. I'm going to do that using the pattern. So 2g and 2g, 1 and 1. 1 is going to be plus, 1 is going to be minus. That's done. Next one here, we've got 12x squared plus 12x plus 3. This one has a GCF of 3, so if I pull 3 out, I get 4x squared plus 4x plus 1. Let's factor the 4x squared plus 4x plus 1. I'm going to use the pattern. I know that my first term, if I square root that, I get 2x. My last term, if I square root that, is 1. So 2x and 1. Let's check to make sure I really do have a perfect square. So 2x times 1 is 2x. Double that, I get 4x. So this is a perfect square. And because my signs are positive, I have a positive for both of those. So that's done. All right, thank you for watching, everybody. Have yourself a great day.